Welcome everybody into this video. In this one we're going to look at the 2023 UK World Skills Automation Regional Qualifier Task C, the PLC task, and in a similar fashion to the 2024 task which we solved in what was the previous video to this one, we're going to tackle this one using the template that was created for the ET200 PLC. So the task is laid out here for 2023. Task C, a programming task, 70 minutes. Again, it's the most heavy weighted task in the regional qualifier. 40% of the marks attributed to the PLC task, Task C. 70 minutes is a substantial amount of time, but there's also, very importantly, 4 time points available for this. So again, a precondition of getting all these time points is that your sequence works. That's the precondition in automation. Mechatronics, there might be additional criteria as well for time points to hold, but there's a lot of time points here available, so it is in your interest to get this solved fairly quickly. So having a look at what we have here, we have what I would describe as potentially 3 separate sequences. We'll have a 2 seconds L plus, and then I would kind of hold it at that. And then I would see this C plus C1 being the start of sequence 1, terminating with a 2 second dwell. C2 being the sequence 2, terminating with a 2 second dwell. And then a C3 starting terminating here, which is the C3 minus, and then the L minus goes off. However, I'm probably going to code this, I will code this using just one sequence and put a step to each one of these. The reason for that is, again, speed. Instead of clicking in or opening up and going in and out of different functions for sequence 1, sequence 2, sequence 3, etc., we can do this all in one function. So from a world skills perspective and thinking about time, that's going to be the main motivator. It's going to be the kind of the parameter that I want to watch. If it was if I was contracted to do this, I probably would split this up into sets of sequences because it'd be by all counts more scalable and potentially more easily navigable. So let's make sure that we're familiar with everything that's in this. 2 seconds, all these 2 seconds are obviously dwells. L is the built-in lamp for starting the cycle, which comes on once and it goes off once in this cycle or sequence. A and B are double acting cylinders. So again, double acting, single acting cylinders makes no difference. It's all about the directional control valve. That's what makes the difference. C1, C2, and C3. C1 is the light beginning the end of the first part of the sequence, say sequence 1 or subsequence 1 if you want, C2 subsequence 2, and C3 subsequence 3. Plus and minus are on and off, effectively on-off status. Circuit requirements, just supply pressure 6 bar, okay. Cycle is to be initiated by actuating a retentive push button switch, PB1 for us. The cycle is to start after 2 second delay, so I press the button, I wait 2 seconds. The light bulb L is integrated into the start button and then that light comes on. The cycle is to self-repeat until the start button is interrupted. So we'll self-repeat that. Once the start button is interrupted, the cycle must complete and come to a rest. So we're going to have to come to a finish state and then we're going to come back and we're going to check is the start button still pressed. If it is, we're going to go again. If it's not, we stop. During the sequence, 3 other lamps are used to indicate the program status. Allocate these to the built-in memory push or the built-in momentary push button switches that you have in your switch box, provided in the TP201 set, C1, C2, and C3. So these are going to be the lamps integral to the 3 momentary push buttons, where in accordance to our template and designations for outputs, these are going to be LGT-PB2, LGT-PB3, and LGT-PB4. Use solenoid actuated spring return for A. That's lovely because that's the way our template is set up, to have a spring return DCV for cylinder A and a double solenoid for B. So that leaves it a wee bit handier. Each cylinder has a sensor to detect its extended and retracted position, so we're definitely dealing with an LOA, L1A, LOB, L1B. Cylinder A has mags and cylinder B's position is determined by any of the other available sensors our switches. So what I'm going to do with this is I'm going to take a copy of this and we're going to allocate steps to this. I'm going to come into here. So this was the 2024 one that we looked at in the previous video. I'm going to add in a page and I call this 2023 Automation Qualifier, Regional Qualifier, don't need the S, and this is task C, of course. Right, so that's the same, looks the same as that. I'm going to paste in this and I'm going to give myself plenty of space. So again, during the competition, this is the first step that you're always going to take even before you open up TAA. When the judge is explaining the sequence, indeed, you might think that this is a good opportunity to start allocating steps, and why not? If the judge permits it and you can take notes down, certainly take them down. But sometimes it could be considered bad taste to do it. So you just have to really feel what the judge will allow and whatnot. Yeah, so I have my tablet here and I am just searching for the pen. Let me just hit a pause here till I find it. Okay, back again. All right, so this is the way we're going to split these up. Just doing the color here that stands out, maybe one that doesn't clash. Let's go for green. So I'm doing this in one sequence, so I'm going to just do this out in steps. So I'm going for 10, and of course I'm going to put this in as T1. This is a light, this is in 20. C1 is another light, 30. This is a counter function, which is going to be 40. And the subsequences, or the sub-steps in it, are 41, 42, 43, and 44. Then I'm going to come on till 50 after the counter. So again, going up in tens. Then I have a 2-second dwell here, belongs in at 60. This is also T2. Right, then I come on into 70. I'm into this big counter here. This counter function is 80. I come into 81 and 82 in the subsequences. I come on to 90 and I come into 100 for T3. Just bracket these off here just to make them stand out a wee bit quicker when I go searching. So again, our template for all our dwells, our template uses a 2-second delay by default. So all this is looking pretty good for me speed wise. So then I'm on to 100, then I come on here to 110. I want a big massive counter function here, which is 120. That breaks into 121, 122, which is also a timer. This is T4. 1, 2, 3, 1, 2, 4, 1, 2, 5, which is also a timer, T5, and 1, 2, 6. That's 120, then I'm on to 130, and finally 140. Okay, so no harm in writing this on your sheet as well, very important. We have T1, my timers, I go down till 5 timers. T1, T2, T3, T4, and T5. Timer 1 is in step 10 and it's 2 seconds. Timer 2 is in step 60 and it's 2 seconds. Timer 3 is in step 100 and it's a 2-second dwell. Timer 4 is in 122 and it's a 1-second dwell. And timer 5 is in step 125 and it is a 1-second dwell. Counters. Counter 1 is in check step is in 40. Check increment step is in 44. And we need to do it by 2. 2 counts on that. Okay, C2 here is in step 80. The check step, apologies, is 80. which is my main step. The increment step is 82, and I need to do that 3 times. Counter 3. Here, it's in step 120 for the check. These are the increment steps. Increment step is 126, and I need to do that 2 times. All right, that's the main bits out of that. Then what I'm going to do is I'm just going to flick back and forth to this to worry about my lights and just pull the numbers off. So what I'll do now is I'm going to come on into TIA. I'm going to open up a new project, and what I'm going to do is I'm going to use the zap file or the archive file from my template. So let's browse away for that. That was the 24 regional one that I had completed. Training, PLC, Siemens, and there's that zap file. Where do I want to save it? Surely I'm going to save it into this automation one. There it is, and I'm going to save as, just to give it a better name. File name, I'm going to put this as 23 auto underscore rage hyphen task C. So that's where we're going to just put it into there. I don't know why it wanted me to put it into there. File name, just put it into there, save it into there. There we go. There's 23. Okay, so let's get into it. So the first thing I'm going to do in this is I'm going to go into my data block. So let's go to program blocks, my data block. We're only dealing in sequence 1 here at the minute. Sequence 1. Right, my timers, I'm dealing with, so navigate back into this, sorry, one note. I have 5 timers in here. So I would be coding this and I would have the sheet next to me, so I don't have to flick back and forth. So time is key here. Timer 1 occurs in step, let me see if I can, I'm going for 10, 60 and 100. Let's try them. I'm going for 10. Function again is 2 seconds by default. 10, 60, and 100. Timer 4, these happen in the counter increments, and these are both 1 seconds. 122 and 125 are both 1 second, so 4 is 122, and the function, I have to change that till 1 second. And 5 is in 125, and that function I'm also going to change till 1 second. Let's make sure that's in 125. It is, yep. That's my timers 100% coded. Counters, 3 counters. Counter 1, my check step is 40, increment step is 44, and I do it twice. So check step is 40, increment step is 44. My reset step, I always use 2 steps down off of this, not including another timer. So after I come into 40, I have 50, 60, and use 60 as my reset step. Function in here is twice, so the same with all my counters, they're all defaulted to be run twice, which will cover the first counter and the third counter. Second counter I need to change. There's counter 1 done. Counter 2, so the check step for counter 2 is 80, increment 82, and I need to do it 3 times. So I'll go for 80, the check, increment in 82, the reset step, 2 steps after that would be 90 and 100, so I can use 100. And the function, I must do this 3 times. There's counter 2 done. Counter 3, my check step is 120, increment step's 126, and I do it 2 times, so my check step is 120, increments 126. This would be 130, 140, but there isn't, oh there is a 140 there. 140, which is effectively the last thing, 0, and this is going to be 2 by default, which ties in to there. Lovely, so that's that done. Alright, so the next thing there that I always do is I do my lights. So go into outputs first, and I code my lights, which are safety independent. Air supply, I can use or not use that, whatever I want. Red lights, amber lights, green light, delete them out if I want. But PB1, according to this, PB1 is L+. starting the cycle. So it represents the built-in lamp there for starting the cycle. Right, so this is going to occur for me. L1 comes on in step 20. Right, so what I'm going to say in this, right, it's not if PB1, but I'm going to say if my sequence, caps lock, see, this is going to be sequence 1 for me, sequence 1 dot W step is greater than or equal to step 20, and sequence 1 dot W step is less than, where do we need to go to, right, L1 140, less than 140. Actually going to keep them up in the same row. Conditions are usually 2, then it's going to be true, or else if any of these conditions are wrong, it's going to be false. So there's light 1 done. PB2 does not have a flash rate on it, so what I'm going to do is I'm going to take that out, right, and we're going to say there that for LV2 doesn't have anything to do with PB1, take that out. So if what C1, if I'm in step 30, right, step comes on in 30, goes off in 50, it needs to be on. So let's take some influence out of this one, Control C. For PB2, if nothing to do with management run sequence in this case, if I'm equal to, greater than or equal to 30, and I'm less than, can't mind what it was, and I'm less than 50, C1, greater than or equal to 30, all the way up there, so long as I'm less than 50. Then that light's true, or else it's false. PB3, so same idea again. For it to be steady, if sequence 1 step is, this is C2, 70 up till 90. Sequence is 70 and it is less than 90. Then light 3 is going to be true. There is no flashing, come out, or else it's going to be off. And finally for PB4, paste in just the greater than equal to less than structure that I use for PV1, and just update the values, the steps. This is the light for PV4 is 110 to 130, goes on in 110 and it's held on through all 120, 121, all the way to 126, but in 130 goes off. So 110 to 130. 110 to 130, it's on, there is no flashing, delete that out, or else it's off. So there's the lights done. Air supply, just going to ignore it. That's fine. And safety dependent outputs now are my actuators. What's this here? Output safety dependent sequence 1. Don't know what happened there. Actuator A, there is no actuator C. You can delete it out or just ignore it. Actuator A is given if it's controlled by a spring actuated solenoid, solenoid actuated spring return. Apologies. And let's have a look at what we have. So in sequence 1, we're 41 to 42, 81 to 82, 123 to 124. Right, so they come back as soon as they go out, so you don't really need a range in here, but I'm just going to keep it as a range. So I'm going to say that A in sequence 1 greater than or equal to 41 and less than 42, for instance. So this is A. There is no sequence 2 or sequence 3 steps. I'm just going to delete them out. So if sequence 1 is equal to, can't even remember what it was now, 41 to 42. That's bad. 41 to 42. Or sequence 1 step is equal to the next one, 81 to 82. Yes. 81 to 82. Or there's a third. Control C, Control V. Or sequence 1 step is greater than or equal to 123 to 124. 43 to 124, then A extend should be true or else A extend should be false. There is actuator A done. Right? B, there's two things to work out in here. We need conditions for extending B and for retracting B. So B extends in 44, 81, 121 and 124. Four extensions in it. So let's try to remember 43 and 81 first. All right. So if I'm equal to 43 or 81, let's take another, I have two more for sequence 1. Control V, Control V. 81, 121 and 124. So 121 and 124. There's nothing for sequence 2, nothing for sequence 3. Let's get rid of all them. Then B extend is true, and just making sure that B retract is false. Or else, let's go for retracting it. Right, so for retraction, I'm in 44 and 82. Let's remember them ones first. This step sequence 1 is 44 or 82. Right, take out all these. And let's get a couple more controls. Oh, apologies for it. These are from before. 82, 123 and 126. Then I should be retract is true, extend is false. There's my actuators coded. There's lights and cylinders coded. Now I need to go into sequence 1. I need to code this. Timers are done because they're all. This here is just referring me back to the my data block. Counters need to be looked after here. So I have 3 counters. Let's take away this 4th counter function here. Okay, the only thing I need to change here in the counters really is this proxy bit. What am I counting in the increment step for counter 1 is LOB. Right, the last thing, this is in the increment step 44. What am I looking at in that? That's LOB. That's DI dot X LOB. That's it. And this should be fine at the minute. All this is saying is that, again, if I'm in my check step, right, I'm not complete, then my next step is equal to my current step, which is my check step plus 1, which means there that if I'm in 40 and this is not complete, my next step should be 40 plus 1, which is 41. It puts me into the counter. And then the next bit says, if I am complete, I go to 40 plus 10, which puts me on to 50. And that's what it says there. Else if it's that and I'm complete, I go to the check step plus 10. So I don't need to change anything in that. Counter 2 function. What am I evaluating in my increment step in counter 2 is both LOA and LOB. So you need to make sure you put both of them in because they might be retracting at different speeds. So I'm going to take in DI dot XLOA and DI dot XLOB. That's it. Don't need to change anything else in that, and my decision is going to be the very same, right? Because I'm not the real change that you'll make in the decision anytime is if the counter completing the counter also completes the full sequence, which in this case it doesn't. It's only going to, the counter check steps either going to put you into 81 or 90, this one 121 or 130. So I don't need to change the decision from what I've allowed for provision wise in the template. Counter 3 function, again the proxy bit, what am I evaluating here in counter 3 function is LOB once again. So let's go for that DI. I should actually have copied and pasted that the first time, but that's it done. So there's all my counters completely coded. Now let's do our steps. So this is handy if I would have the two of them opened up together. All right, this is also where I need to look at my outputs. So T1 is what I need to look at. So if I am 0, A and B are both retracted, these are just double check steps again. A and B both should be retracted. and all that, then I go ahead and I should move myself into 10. Right, so 10 is my first step, and 10 is where I start my timer. So if I'm equal to 10, I'm going to take out my timer here. That's in my template. So if I'm equal to 10 and timer's complete, then go on into 20. If I'm equal to 20 and my light 1 goes on. So light 1, there's no input to confirm that the light is going on, but I want to check my output. Right, so I'm just going to check my output there to be safe. So it's not a DI, this is obviously a DQ, and that's why I bring in the DQs into the sequence ones. Dot XL light PB1, and that then go on till 30. So in 30 I get PB2 light. So I'm going to just copy that, Control C. If I'm equal to 30 here, and take the and as well, PB2 light, then I go on into 40. If I'm equal to 40, 40 takes me into my counter, so that's looked after in the counter section. I need to code what happens in 41. Right? So then I go into 40. If the counter decides to put me into 41, and I get L1A and DIL1A, I'm going to put that then down to the bottom. That's my last one. Sequence complete is true. Right? And I'm just going to Control C and put that into there. Then I'm going to go into 42. And what I'm going to do is take the whole lot of that now. Else if I'm equal to 42 and I get LOA, I think I can remember it being LOA going to 43. If I'm equal to 43 and LOA, L1B and then LOB, and L1B, I go to 44. If I'm equal to 44 and I get L1A, LOB, apologies, LOB, 44, I get LOB, then I go back to 40 and I check again. Now when I'm back to 40, obviously the counter up here is going to check me again and see they're going to say, right, I need to put you back into 41 or else I need to put you on till 50. So I'm going to assume here that it's now put me on to 50. So it's the counter there that puts me to 50. There's nothing down here I say else then sequence step is equal to 50. That's done up there in the counter just by way of remembering. So 50 there is the PB2 light goes off, so which is this one here. Right, so if I'm equal to 50 and not the light, then I'm going to move myself on to 60. And then obviously in 60, I need to run my second timer, which I'm going to take this one here. Else if I'm equal to 60 and timer 2 function is finished, then move yourself on to 70. It's now down to here. So 70, I'm going again for my C2 light in this. So I'm going to say Control C. Else if I'm equal to 70 and I get my PB3 light, then move myself on to 80. I believe I'm into another check step here, which I am. So the counter C2 is going to take that. I'm going to assume there it's going to fire me on until 82, say, or sorry, 81. So let me just take these here, not for any other reason, but it's just that it has ones in it. 81. These are firing too. This is L1A and L1B, so and L1A and DI.X L1B. Then go on ahead into 82. Then in 82, they both come back, LOA and L1B. So I'm just going to take this one, Control C, Control V. if I'm in equal to 82 and LOA and LOB, then put you on back into 80, isn't it? Yeah, 82 goes back to 80. Yep, it's only 2 steps in that. Now I'm going to assume that it's going to push me on to 90, which is going to turn off my C2 light, and then until 100, which is my timer function, which is like these two here. It's very same as them. Right, so I'm going to take these here. Control C, Control V. So else if I'm equal to 90 and my light, then you go on ahead until 100. If I'm equal to 100 and timer 3 is finished, then move on into 110. When I'm into 110, I should see this light come on, the C3 light come on. So I'm going to take this one here just for convenience. If I'm equal to 110 and take the not out, this is going to be PB4, then go on to 120, which is another check step. So I'm going to assume there now it's going to put me into 121. The counter function is going to put me into 121, which is an L1B. LOBs. Just wasting time here looking for this really. So I'll just take a couple of these here. Then take these here. Sometimes I don't like taking too many because you're there, flip, where do I start here? But anyway, I'm into 121 and 121 and I get L1B. 121 and L1B, go to 122. If I'm equal to 122 and this is a timer, T4. Let's see, can we find a timer up here? There's a timer. Control C, 122 and T4 timer. Then I go to 123. If I'm equal to 123 and I get L1A and LOB, and it's an LOB, put my A's first, and DI.XL1A and XOB, then go on to 124. If I'm equal to 124 and LOA and L1B, so I'm going to invert these. And I get LOA and L1B, then go on to 125. If I'm equal to 125 and I get my other timer, which I'll just take this one here. If I'm equal to 125, take the whole lot of it, Control C. If I'm equal to 125 and timer 5 function Q, then I'm going to move myself back to back into 126. There's a 126 on it, and then I'm into an LOB again. Let's take any of these here. Control C, 26. If I'm equal to 126 and LOB, nothing to do with L1B, then go back to 120, my check step. So then 120 might fire me on to 121, and I'll have to do all that again. 22, then I go to 123, 123 to 124, 124 to 125, 125 to 126, 126 back to 120. 120 then might fire me on to 130. So I'm on to that light. I want to turn it off, so it's an and not. Right? I'm going to take these ones here, line underneath it. So if I'm equal to 130 and not, push button 4, go on ahead there to 140. And then finally, if I'm equal to 140 and not push button 1 light, right? Which this is the last thing, is that this L minus here has to come off. If I make it to 140 and not push button 1 light, then my sequence is complete. And if. Okay, so that's the sequence coded. Okay, now last thing the code there is management. So there's no timers, no counters to be coded in this. Everything's fine. The safe status in this, again, we're not going to be able to execute our outputs, our safety dependent outputs with this template, given that I have a precondition that this must be in a safe status in order for it to run. And the only way it can have a safe status is if I see 24 volts at my e-stop input and at my safety light curtain input, which we don't have safety light curtains or anything or an e-stop in this, so these are going to be low, then that pin is going to be low, and because of that this is going to say this is unsafe and I won't be able to operate it. So what I normally would do in this is that I'm going to set them high here, but then I also go into the CP interface and I force them high and make them high. I just say that they're high. The reason I write them high here is that it's a reminder whenever I look into safe status that I have done something odd, okay, which is di.x e-stop. I'm going to set that equal to true, which it will be true in this, but overall it won't be true because in the CP interface it's going to be, it's monitoring the input pin. X safety light curtain is true. Right, so it's just that there simply there as a reminder. It's not going to have any effect really on this. What I do need to do is change it in here, the CP interface. So at the minute here I have e-stop is going to be monitoring that pin. I'm just going to say it's true, and instead of monitoring that pin I'm going to tell the code that it's true. That's them there. All right, so that's if you're going to reuse this version of the template or whatever for another thing, for another code or another solution, you do not want to forget that you've done that, because it causes you all sorts of trouble. But that's why it's written there. Just off flip right, there's something, I want the CP interface and I changed it. For scan, that's all fine. There's nothing really to change in that one. Initial conditions are dead on. This is just saying that A, B, and C are to be retracted. That's standard in the template, and that's what happens in this code. The sequences, right? So we're only running sequence 1, don't need to run anything else. But what happens at the end of a sequence? Okay, so this is where we're going to take in a little bit of usage out of this template. At the end of the sequence ends. That's it. At the end of this, if I'm running sequence 1 and that sequence is complete the way I left that sequence 1, what do I want to happen? Well, I want to put myself into run mode 0, run sequence 0, one step gets resetted to 0, and the faults or the sequence completed gets falsed again, turned off. Right? But you say, here, well, this is meant to repeat, so surely I should be repeating that. Well, yeah, but we also want it there that if you have, let go of the retentive switch, that if you've deactivated it or unactivated it, and that it stops. So it has to run to the end. I need to set everything back to 0, and then I need to check, is this still pressed? And if it is still pressed, then I'll kick myself back in automatically, in this case. Okay, so to start the sequence, if management run mode is equal to 1 and sequence is equal to 0, then run sequence 1. So the thing is, I just need to go from 0 into 1 every single time that this is finished. And the way I'm going to do that here obviously is in the mode. We're starting mode 1 because mode 1 is defaulted to run sequence 1 by the way this is. So if management run mode is equal to 0, which it will be, and the dedent button is pressed, then you go into mode 1. That's it. Don't even worry about mode 2 here. You can comment them out, because it could be a case that if you did press, if you wired that button was wired, which it really shouldn't be, but you did wire that button, you pressed it, that could stick you into run mode 2, which you don't want to happen because you won't be executing anything. So maybe a safer thing to do in this eventuality would be to delete out, get out of that region there as well. Region modes, region 1 mode, and region, which region am I looking at in here? Let me take that one out. Yeah, So I'm just running mode 1 in this mode region. That's just, you don't have to do that, but it's, look, it's just in case that you did, where the third push button, the second momentary push button, or even the last one, and you pressed it, will kick into the wrong mode, and you could be scratching your head on what's wrong with it. But other than that, that's the job done. There is one thing I wanted to check because wasn't apparent to me straight away, was this A plus B minus, that A and B were going opposite ways. I just want to double check my outputs to make sure they're right, but I'm sure they are because I was working them off the numbers. Outputs safety dependent are my actuators, and if I have one of them I should have the other. I should check B. So the B extensions are 4381, 121 and 124 for B extensions. 40 open that up there to the background. Maybe just see if I can do that and that. Alright, let's scoot that over here. Let's see B extensions. So B extensions for me are 43, 81. B extension is there 121 and a 124. B retractions are a 44 and 82, a 123 and a 126. That all looks good. B is brilliant. A, let's just double check it. A wee bit more to look at in this one. A extends in 41 and retracts in 42. Extends in 41, retracts in 42. Extends in 81, retracts in 82. Extends in 81, retracts in 82. Extends in 123 and retracts in 124. That's it. All right. Lovely. So what I do is I would typically close down all of this. I'm just going to open this up slightly again. I would always go into the main OB. I'll just check to make sure that there's no big X's in that. Sequence 1 will run off of that. Outputs, and it'll access any sequence except 0. That allows the initial conditions in the management to work. Yeah, after that, that looks all good. Click on Sean's PLC. Let's compile. I should get 3 warnings on this, which I do. These again are all to do with my usage of the OPC UA server and not having passwords set or any sort of configured protection levels involved. But every subsequent time now that I compile this, they will not they'll not show up them warnings. That's it. So I'm going to save that project, and then what we'll do is we'll download that on into the PLC. Start a search for this PLC. There it is. Load, and I'm going to continue out synchronization. Everything looks good. Load. Make sure there's no errors. Finish. That's it done. All right, so that's 2023 Task C done for the regional qualifiers. I didn't time myself on that one, but again, there's 4 time points for it, 70 minutes allowed for it. This video has only gone on for 43, so if we only coded it and we didn't do any discussion or anything on this, and provided there's no errors in it, we'd have 25 minutes here to spare. And that is another thing. I seen a very interesting thing there today, and it was on about coders using debugging and bugs and this and that, and confusing a bug, not confusing, but calling errors bugs. If you try to execute this code and it does not work, you've created an error. You've made an error on this. It's not a bug. It isn't something there that has been out of your control. It is executing exactly what you have put into it. So don't be afraid to say you made an error if it doesn't work. Now I don't have hardware here to test this on. I'm confident now with what I've done that this should work. I don't see any reason why it wouldn't, based on what I know of the template and how it works. But yeah, if you have coded this and exactly like this, and you've downloaded into your PLC and your hardware and your setup and your wiring and everything's 100% correct and it still doesn't work, then yeah, there's an error in the code. It's an error I made if you've done what I've done. So yeah, test it, see how it goes. Download it into your PLC, set it up in accordance to that task, and try it. Um, Time this method against your own methods of programming the PLCs and see what what advantages this might have, what disadvantages it might have, or where your own method might have superiority in certain fields, and yeah, adapt it. Make your own template and keep pushing, keep improving. But make sure you let me know what you're doing as well, because I'd be very interested in this type of stuff. So, yeah, I'll keep on pressing, solving these regional tasks for automation, and then after the regional qualifiers in this 2026 cycle, I'll move on and we'll start solving for the national finals, which are absolutely phenomenal tasks, I have to say, and I will look forward to them. So if you haven't done already, hit the subscribe button so when these videos are rolled out, you'll be notified straight away. Again, 2 months there to regional qualifiers, so hopefully this helps you prepare, and hopefully you found it interesting even if you aren't going ahead to compete in World Skills this year. Okay, thanks very much for joining.